Your Kubernetes deployment is ready. Your pod looks healthy. Your YAML files look perfect. And yet, your persistent volume claim refuses to bind. Your pod is stuck in container creating stage, and Kubernetes says just one word, that is pending. No error, no warning, just nothing. Before we dive into this storage nightmare, hit like right now so YouTube pushes this episode to more engineers who want real world Kubernetes debugging, not boring theory. Welcome to episode 3 of the Kubernetes Simulation Series. In episode 1, we fixed crash loop backoff. In episode 2, we debugged a service that routed to 0 pods. Today, we take on the most confusing storage issue DevOps engineers face in Kubernetes. A PVC stuck in pending forever. Nothing in Kubernetes wastes more hours than storage misconfiguration. I built a small Flask application and deployed it with a persistent volume claim. Let's apply everything. First, I'm going to run kubectl apply -f k8 pvc.yaml file. Press enter. Persistent volume claim created successfully. Followed by, we are going to run deployment.yaml kubectl apply -f deployment.yaml created successfully. Now let's check PVC. Press enter, and right away we are in trouble. Your PVC is stuck in pending, which means your pod has zero chance of starting. Let's confirm. kubectl get pods. Press enter. Status pending is Kubernetes speak for I'm waiting on your volume, bro. It will sit like this forever. Let's check the PVC details now. For that, I'm going to run kubectl describe PVC demo PVC. Enter. I can see some events here. For example, type warning provisioning failed, and also I can see the message fast storage not found. This is the key. Kubernetes is literally telling us the storage class you asked for, fast storage, does not exist. This one line explains why the PVC is stuck in pending. In Kubernetes, if your storage class doesn't exist, your volume will never be provisioned. Your pod will never start, and the PVC will sit in pending state forever. Now let's check which storage class actually exists in this particular cluster. I'm going to run kubectl get storage class. Press enter. I can see host path. This list tells us the real storage providers available on this cluster. I have only one at the moment. Fast storage is not one of them. I'm going to copy this. Let's try to open pvc.yaml file. I'm going to update the storage class name here. I'm going to remove this and replace it with host path. This tells Kubernetes use the storage provider that this cluster actually supports. Now we are going to recreate the PVC. First of all, I would like to delete the PVC. Now I'm going to recreate the PVC. kubectl apply once again. Press enter, followed by. Now let's restart the deployment so the pod can mount the newly bound PVC. Press enter. Once again, we are going to run kubectl apply deployment.yaml. Press enter. This ensures the pod attaches to the correct storage. Now let's try to run kubectl get PVC once again. Press enter. If you see the status now, it shows bound. Followed by, I'm going to run kubectl get pods. Press enter. It shows running. That's what we want. PVC is bound and our pod is successfully running. Storage is successfully mounted. One wrong storage class name broke the whole deployment. One correct storage class name fixed it. Let's look at the lessons that we learned from this episode. When a PVC is stuck in pending state, there are only a few real root causes. Number one is storage class does not exist. Number two, storage class name is misspelled. No dynamic provisioner. PV size mismatch. Access mode mismatch. But in 90% of real world cases, it's exactly what we just saw. Wrong storage class name. The cluster cannot provision what it does not support. And that was episode 3 of the Kubernetes Simulation Series. This is a real production style debugging story, not a toy example. If you want me to continue this series and break down even deeper Kubernetes outages, comment episode 4 right now, smash like button, hit that subscribe, and I'll see you in episode 4. We are debugging a pod stuck in pending state because the node has no resource left. It's going to be crazy. Thank you for watching and see you in the next video.